So in this video, we're so um, we are building an AI system that understands users' intent and routes requests to the correct tool or category. Example: the sentence or the text summarized this article is its category is summarization, and if we have like for example explain gravity text, its category is therefore Q&A. If it is write a poem, it is creative writing. This project teaches how we build the dispatcher using the Databricks DALL-E 15K datasets, DistillBERT, PyTorch, efficient fine-tuning strategies. So here's the big picture of the project. The pipeline is from the raw text tokenization, tensor conversion, DistillBERT, classification head, and predicted intent category. So the goal is to input, like for example, we input the summarize this article as text. So its output is information distillation. What is dataset? So the Databricks $15K. The dataset contains instruction, response, and category. Like for example, we have the instruction explain photosynthesis. This category is open Q&A. If we have the instruction like summarize this article, its category is summarization. If we have the instruction write a poem, its category therefore is creative writing. Next is dataset augmentation or back translation. So in the project, professional natural language processing augmentation technique is back translation. For example, the process from English to German, Arabic, or etc. is to back into the English language. Like for example, the original "What is AI?" is translated back. Can you explain artificial intelligence? Meaning stays same. Wording just changes. So the benefits is more diverse training data, improves generalization, model learns meaning instead of memorization. Next is loading the dataset. We have like for example, we use the Panda to read the CSV. Okay. So what happens there? We have the PD that reads CSV. It loads the CSV into a data frame. And what is that graph now? It removes rows with missing values. What is it's important? Bad or missing data can break training. What does means that reset index drop is equal to true. Reset row numbering after deletions. Next is understanding categories. So the original dataset contains many categories. Examples: open QA, close QA, general QA, summarization, and information extraction. Next is category consolidation. So in this project, we merge similar categories. Like if we have the this list, or I mean the dictionary category map, we have the general QA and it's equivalent to Q and A, etc. Why we merge categories? Because it simplifies the classification task, reduces confusion, improves robustness. Instead of learning many similar classes, model learns broader intent. Next is label encoding. Neural network cannot understand strings, so categories become numbers. Example, we have the cat to ID. Q, like for example, this categories Q&A is its numerical value is 0, classification numerical value is 1, creative writing is numerical value is 2. Then we have the data frame and we map it. Next is reverse mapping. We use the ID to get. So its purpose is to convert predictions back to readable text from number to its label value. Next is extracting inputs and labels. So we have the text and labels. So the data frame instructions list and data frame label list. So like for example, its value inside of the data frame is what is AI, summarize this, and its labels value is 0 and 1. Next is DistillBERT. So this is a core model use. So DistillBERT is smaller, faster version of BERT. Benefits is faster training, less memory, good accuracy. What BERT actually does: BERT learns language context. Example, word bank. Meaning changes depending on sentence. BERT understands context using attention mechanism. It learns which word should focus on others or other words. Next is tokenization. Before entering the model from text to token, learning is amazing. So it splits like we have machine learning is amazing. So those forward has different numerical IDs. Next is attention mask. Attention mask tells model which tokens are real and which are padding. Like for example, we have the IDs inside this list: 101, 2023, 2003, 102, 0. So the mask value converted to 1 and 0 is ignored padding. Next is custom Python datasets. So the purpose returns this kind of dictionary. Why this dataset class exists? It allows lazy loading, batching, efficient training, GPU-friendly pipelines. Next is data collator. Role: it combines multiple samples into batches. So single samples, like we have the sample 1, it has 20 tokens, sample 2 45 tokens. Collator pads them to equal length. Next is padding. Neural networks need same tensor shapes. Example, we have the numerical values 1, 2, 3, and the other one is 1, 2, 3, 4, 5. So it becomes 1, 2, 3, and the other one is its remaining value is 0 to make it equivalent length as the largest length in the list. Next is data loader. Data loader handles batching, shuffling, multiprocessing, efficient loading. So its pipeline is from dataset, data loader, to batches, to GPU. Validation set. Its purpose is training set, used for learning. Validation set is used for evaluation on unseen data. Next is class imbalance. Some categories appear more frequently. Example, class Q&A. It has samples of 10,000, but the brainstorming class is only 500. So the problem is model becomes biased towards large classes. So what is weight class? This is a solution. Assign larger penalty to minority classes. So in the laboratory, we use the function compute class weight. So the formula idea is class weight is inversely proportional to class frequency. So the meaning, rare classes get higher importance. Next is cross entropy loss. Classification commonly use cross entropy loss. Normally, wrong prediction is equivalent to penalty. The weighted version is rare class mistakes, larger penalty. Rare class mistakes is larger penalty. So what is tensor conversion? Weights converted into tensors. So we have the code storage the tensor weights because PyTorch models operates on tensors. Next is efficient fine-tuning. One of the most important concepts. Instead of training entire BERT, we freeze most layers. Freezing layers. Param that requires period false, meaning we do not update this layer during the propagation. Why freeze layers? It benefits faster training, lower memory, less overfitting, cheaper computation. This is very important in real world large language model system. Also, partial fine-tuning strategy is train only the last transformer layers classification head. So the reason for it is earlier layers already learned general language, later layers adapt to task specific patterns. What is Dieselbert architecture? Dieselbert has 6 transformer layers. So in the laboratory, we only validates 0 is 0 or 0 less than or equals to layers to train to less than or equal to 6. Meaning the number of layers trained is from less than or equals to In between the range of 0 and 6. 0 and 6. Training hyperparameters. Main hyperparameters from learning rate is meaning step size, number of epochs is number of passes. Layers to train is how many birth layers to unfreeze. Next is learning rate. Control update size too high, training unstable too low, training very slow. Epoch is one full pass through dataset. Example, 5 epoch is dataset seen 5 times. Training loop does forward pass, compute loss, back propagation, and updates weights. Next is forward pass. Model predicts outputs, input to prediction. What is loss computation? Measures error. Lower loss is better predictions. And back propagation computes gradients. Core idea: how should weights change to reduce loss? Next is optimizer. Uses gradients to update weights, likely using Adam W, popular for transformers. Next is validation metrics. So in the laboratory, we evaluate loss, accuracy, and F1 score. So what is accuracy? Accuracy is the correct predictions out of the total predictions. What is F1 score? Very important for imbalanced datasets. It balances precision and recall. So high F1 means good balance performance. F greater than 0.8. What is confusion matrix? Shows which classes are confused with others. Example, the actual brainstorming. So, but the model predicted creative writing. Useful for debugging model releases. Next is evaluation on unseen prompts. This is the final test. Give brand new to instructions. Example, explain water cycle. So the model predicts Q&A. This test, generalization, is a more important ability in machine learning. So here's the key real world natural language processing concepts we must keep in mind. So tokenization, attention masks, transformers, Dieselbert, fine-tuning, batching, weighted loss, style training, evaluation matrix, and confusion matrix. So we do not always train the whole model. Modern AI commonly use partial fine-tuning, LoRa, adapters, and freezing because gen models are expensive. Next is hyperparameter hints. So in the laboratory, we secretly suggest that we should have the layers to train for. Learning rate is 5 e minus 5, and number of epochs is 5. So this help achieve loss must be less than 0.7 and F1 should be greater than 0.8. So here's the rebuild from the user prompt to tokenizer to the Dilbert to classifier and an intent category. So this foundational architecture used in chatbots, AI agents, tool routing systems, customer supports, AI assistants, and automated workflow. So pre-trained models already know language. We fine-tuning only to teach us how to apply that language knowledge in our specific task. That's why transfer learning is so powerful. So these are terms we use. Tokenization is to text to tokens. Attention mask is tells model what to ignore. Tensor is numerical structure to deep learning. Data loader is batch provider. Fine-tuning is adapting pre-trained model. Freeze layers prevent updates. And weighted loss is fixed class imbalance. And epoch is one dataset pass. F1 score is balance metric. Generalization works on unseen data. And that's